Hello everyone. In this video, we are going to see how to automate an important step in the software development lifecycle, which is creation of class diagrams. So before going into how to automate, let me quickly explain what are class diagrams and why it is useful to create them. Here on the right side, you are seeing an example of a payment gateway class diagram, which will contain several blocks, and each blocks represent a single class, and each class will have certain attributes and method signatures defined to them. There are also interconnections between classes, like this payment service uses this payment gateway that is represented by a normal arrow, and this stripe gateway inherits payment gateway that is represented by an inheritance arrow. So this is PlantUML. I'm not going to dive deeper into how PlantUML works and what is the syntax of it. There are a lot of videos that covers it. The goal of this video is how we are going to automate and code base into this code and convert that into an UML PNG. So how we are going to do that is with a package called py2pyml, which will take a Python code base and that will convert it into an PUML code automatically. So the example that I am using is Python, but it's not limited to Python because there are other languages like tplant which will convert TypeScript code into PlantUML, and there are a lot of other language support also. So for this example, let's stick with Python. So the first step is to install py2pyml package, and the second step is to use the py2pyml command to convert the code base into an PML code. So I have created an utility that does this for you. So you can just copy this utility and move that into the target code base that you are going to convert. So the step 3 is optional, which is to convert PML code into PNG. As you see, you can just copy this PML code here in the PlantUML editor and you can get the image. So why we are having this optional step is here you can have a privacy concern, like the class diagram will have the business logic of what you are going to create, and that cannot be exposed in certain cases. So you want to do if you want to do this offline, you can follow the third step, which is you need to install Java and a jar file which will convert the PlantML code to PNG offline. So after completing the installations, you can just configure the module name and run the script, and it will convert the code base into PNG. So let's see things in action. I have took pandas as an example. Pandas is an popular open source Python repository for data analysis. So here in the main script, I have mentioned module as pandas.io, which is a sub package in the pandas. So pandas will take a lot of time to compile. So I am just using a sub package in the pandas. I have mentioned that one. I have also mentioned the jar file, like the script and the jar file that I mentioned. I have placed them inside a folder. When I triggered the conversion, it converted and generated 3 files. So what are these files? Where the PUML file is the actual PUML code that is being programmatically generated from our code base. You can see the classes defined at the top and the interconnections between the classes at the bottom. So the PNG is our main area of interest. So this one is the class diagram that is being generated. So here let's quickly walk through what it has. So our area of interest is only pandas.io, so it captured that folder, and inside that folder we have many other files, like XML is a file, stata is a file, and there are also other folders here like SAS, parsers. So you can see that SAS is a file, and that has SAS reader, SAS constants. So it will recursively go through every file that is in your code base, and it will generate an class diagram for it. So let's take any one as example and walk through the classes here. So let me take this one, PyTables, as an example. Yeah, so I'm going to search for a particular class. Let's take this one, appendable frame table. So this is defined here, and this inherits appendable table, and that inherits table, and that inherits, you can see the arrow goes here, fixed. There are also other information that are available, like this table is using the selection class. So if we search for selection, yeah, here you can see there is a private method inside table, and that method initializes this selection and uses it. That is also being captured as part of our class diagram. So creation of class diagram using this way will be very useful. uh, I'm going to also explain what are the other use case of this. So let's walk through them. So the main thing is you can easily understand open source projects. The example that I shown here is pandas. Like I'm going to contribute. I'm going to fix an issue in pandas, but the code base is very vast, and I don't know uh, how the code base works. I can just run the script and get an overall picture of what are the classes and how they are connected to each other, so that I can understand them better. That is the one main use case. And the second thing is not in open source project, but let's say you are developing a project and you want to make sure the class diagrams are always in sync with the code base, which means usually we will create class diagrams in the beginning of defining a feature. If we define a feature, we will create a class diagram, we will get approval, and let's say after a few weeks we are getting a change request or a bug fix, we will directly touch the code, and there is a high possibility that the class diagram will be out of sync with the code base. So by deriving the class diagrams from the code base, we are making sure it is always in sync, which is an advantage. So the third thing is it's better to make class diagram undergo peer review process. So what I mean is it is difficult to compare two images, right? So typically class diagrams will be images. If you are making a change in the class diagram, you are generating a new image, and you cannot, it is difficult to compare two images. But if it's a text representation like this PML code, using the version control systems like Git, it can be easily compared. And the next thing is it enforces clean code and clean architecture. So if you look into the class diagram, it is just a representation of your code base. Like the classes are inside which folder, what is the name of the class, what is the name of the attribute, what is the signature of the method. So everything represents clean code and architecture. You can review this class diagram, and you can make some corrections to ensure the code base is always following clean code and clean architecture. The last and final thing is we are doing everything automatically in a version control system. So in future it will help us analyze how our class diagram, how our code base changes over time. So these are the advantages of using this one. I hope you like this video. You can comment you can provide your feedbacks in the comment. Thank you.